Hey guys, so in this lecture we are going to discuss about the Zscaler Private Access Architecture, that is ZPA, right? So basically, how Zscaler has simplified the remote access with ZPA, right? So when we talk about remote access service, in traditional environment, what used to happen, we used to have devices on edge, right? Be it your SD-WAN device or your firewall, and it is having internet connectivity, MPLS connectivity, whatever it is, as your underlay connection. Okay. And then you used to have your infrastructure, your LAN, DMZ, right? So whatever critical resources you use to host over the DMZ or your LAN infrastructure, if users are working from home, you need to provide them access, right? If any user is working from home and they are also connected with their ISP, right? Then you need to provide them a mechanism so that they can access the internal resources without exposing their connection over internet, right? So we do it with the help of the remote access VPN. We used to do it earlier. So what used to happen, clients used to establish the tunnels with the gateways, right? And as per the defined policies, clients used to get the access to certain subnets or all the subnets. That is your default route. It depends upon the remote access VPN deployment, whether you are running in split tunnel mode or all tunnel mode, right? So whatever subnets you're getting from your gateway, accordingly your packets will move over the tunnel and you will be able to access your internal applications. But there was a flaw in this model, So when everyone started working from home, these devices, your edge devices, they started facing performance issues like high CPU, high memory, right? Because initially organizations were not prepared for complete work from home, and when they deployed the gateways or your edge devices with full tunnel, so entire user traffic was coming to the device, and then a device was taking decision. Let's say if this user would like to go over the YouTube or any social networking website, so packets were coming over to the gateway, and from gateway they were going over the internet, right? And if user is trying to access any internal application, so then also packets are coming here, and then gateway was routing the packets towards the internal infrastructure. But later on, organizations made the decision and they switched to split tunnel, where only internal application traffic came to the gateways, and rest of the public sites and normal internet traffic left the physical interface, or that didn't come to the gateways, to reduce the memory, CPU and all that, because during lockdown it was really difficult to upgrade these devices. Okay. So now, how Zscaler has simplified this problem. So, what was the, what were the problem in this particular model, right? Or why it was exposing the entire infrastructure, to the attackers? So, let's say when you're not using your VPN adapter to connect to your gateway, and you are normally surfing internet with your laptop, it might be possible that you can infect your machine, right? It is possible that you can infect your machine. Once your machine is infected, when you connect to adapter, VPN adapter, that malware can travel over that tunnel towards your infrastructure. And from there, it can go anywhere, right? Because you get the access to entire network, right? Whatever subnets you are getting access to, that malware can travel along with those subnets, right? So this is how you are exposing your network to a infected device, right? So this is also, in pandemic, we have heard of this term ZTNA, Zero Trust Network Access, which says that we are not going to give you the complete network access like we used to do it in traditional VPN solutions. Now you will be getting access to those applications which are required for your day-to-day work, right? So now app access will be user based. So whatever is your user ID and whatever is your job role, accordingly you will get access to those applications. You will not get access to complete network. So if this laptop or desktop gets compromised, or let's say it is infected by any malware as well, so it is not going to harm your entire network. Only few applications will be exposed to this machine, right? So this is how ZTA framework, underlying principle is, and we would like to implement that particular thing. So Zscaler has provided you the solution for that, right? So during your journey towards the ZTNA, if you go with Zscaler Private Access, it's like you are putting efforts in the right direction, right? You're not exposing your entire infrastructure to your employees, to your contractors, vendors, wherever, right? So let's try to understand how Zscaler has simplified the remote access with the ZPA service. So here you don't need any physical application, or any physical appliance. My bad, not application. Any physical appliance on premises which will take care of your private connections. No need for NAT configuration. No NAT config is required, right? No components in DMZ zone are required, right? This is from network perspective. When we talk about from application perspective, automated application discovery is supported, app discovery, dynamic per session discovery, right, is also supported. Then when we talk about scalability, so you can add app connectors for redundancy and scalability as per your load, traffic load. Currently, what Zscaler is supporting when we talk about ZPA, so currently it is only supporting client to server communication. It is not supporting communications starting from server side towards the client. That is your push connections, right? If server is initiating the connection towards the client, this is not supported as of now in ZPA service. Peer-to-peer connection is not supported. Example SIP. So this is not supported over ZPA, right? Then we have broadcast, multicast. Broadcast is not supported. Multicast is not supported. ICMP is not supported. And active mode FTP is not supported. So these are the services which are not supported as of now over ZPA service, right? They are in the roadmap, but as of now, they are not supported. And initially, whenever users were accessing the applications, inspection, was not there. But now Zscaler has also introduced the inspection. So it's like, the competitors like Palo Alto Prisma, they were taking this advantage that Zscaler is not inspecting the applications in their private access service, right? So whatever traffic is going through the private access service, it is going uninspected. No protection is there at header level or at network level. Nothing is there, right? But now Zscaler has introduced the inspection policy as well for private application. So if I will give you the connectivity overview, right, how it is going to look like. So this looks like something like this. So this is your Zscaler private access cloud, right? We have brokers and we call them ZPA private service, these are your public private service brokers, right? Which will be helping you out to facilitate your connections and you can reach out to your applications, right? So just like in ZIA, we used to have Zscaler enforcement node or ZIA public service edge. Similarly, these are your ZPA public service edges, right? So now you can configure this with the help of your ZPA admin UI. Just like we have admin UI for ZIA, similarly we have admin UI portal for ZPA service. And from there, you can configure this. And we do have central authority, right? Zscaler central authority, which is controlling all these things, right? So you are going to configure your central authority with the help of the admin UI, and then central authority is going to take care of these public service edges and your connections, right? So let's say this is the Zscaler Private Access Cloud, and you have your own data center here, your private data center. You have your AWS cloud here, where you have hosted your applications, your private cloud. Okay. Now what you need to do is you need to spin up the app connectors, right? On premises, right? So these app connectors will provide you connectivity with your application servers, be it on premises or over the private cloud, right? Similarly, your users needs to have ZCC installed in their laptop to access private applications. They need this application, Zscaler Client Connector. Now, what is going to happen? ZCC is going to establish one outbound connection, that is your TLS connection, with nearest ZPA public service edge, right? It will be used to communicate with the CA, right, and to receive necessary information like what are all the applications which are uh, accessible through this service, or if you have configured your forwarding client policy, so whatever allowed applications are there, those lists will be shared with you from the Zscaler central authority, right? So now what is going to happen? Similarly, app connectors are going to establish outbound connections with nearest ZPA public service edges devices, right? So let me just denote them, Zscaler public service edges. So we will have these outbound tunnels. You can also call them Z tunnels. So for ZPA service, your Z tunnels will be in the picture. Okay. So now what is going to happen whenever any user is request for any application which is accessible through the Zscaler private access service, right? So your ZCC is going to intercept that particular request, and it is going to redirect that particular request to a synthetic IP, which we also call it ephemeral IP, right? And that will come from this subnet. So if you do NS lookup for applications which are reachable through ZPA service, you will see that you are getting the output, the output for that particular NS lookup query from this particular subnet, right? So this is the ephemeral IP which you are getting, right? And this is how Zscaler is protecting your real servers. You're not exposing your real server IP addresses. So in traditional network, if you're going to connect through VPN adapter, if you do NS lookup to your local portals, you will get the direct IP addresses of your app, of your servers, internal servers, right? So this is how you expose your internal servers to your machines, to your employees or whatever it is, right? So Zscaler is providing you the protection at network level. So that protection is you will first get the dummy IP. Now this is the ephemeral IP. You're not even sure where your actual server has been hosted, whether it is there inside the private DC or it is there inside any cloud, AWS, Azure, GCP, right? So you're not even sure where your application server has been hosted. This is the first level of protection you get from ZPA service. Now your ZPA central authority is going to validate your request, and then it is going to uh, you know um ask the nearest app connector to form the connection with the broker, so that you can have your communication further going on, right? So let's dig in more into this, how it is going to work, right? So basically, before moving to this, let me give you more insight, right? So basically what happens whenever you're going to enroll for this particular service, right? So a device fingerprint is captured, right, with the unique data from the host device, so that we can prevent any possibility of cloning the client connector and its certificate for unauthorized access, right? So whenever you enroll with the ZPA public service edge, you get the certificate, and that certificate has been signed by the subordinate CA for clients on the ZPA instance, right? The private keys and the certificates are stored securely within the client connector itself. And whenever you are going to do the re-enrollment, these private key and certificate are going to renewed each time. So if the administrator disables ZPA for that device through a force remove operation at the Zscaler client connector portal, these certificates and keys are automatically revoked, right? So this is how we prevent unauthorized access. Similarly, when we talk about app connectors, so when app connectors are going to boot, they are going to call home, and that is your Zscaler cloud. And they will establish an outbound encrypted TLS connection to the closest healthy ZPA service edge. This connection is used as a control channel to allow enrollment and configuration of app connector, right? And it will be also used to notify the application discovery whenever any app is discovered through the app connector. So the enrollment of the app connector is secured through a provisioning key that is signed by the specified subordinate certificate authority for app connectors on ZPA instance. I mean, we are going to uh, walk through all of this during our following lectures, right? Right now, I'm just trying to give you an overview how securely these connections are established, right? And how we are making sure that any unauthorized access can be prevented. Okay. So this is how both GCC and app connectors are authenticated, authenticating themselves, and Zscaler Cloud is issuing them the certificates which are, unique to them, and they are going to store it secretly. Nobody can clone that information. And from device perspective, we will capture unique information like CPU ID, hard drive serial number, battery unique ID, so that we can create the fingerprint of the device, and then nobody can clone that particular device and gain the unauthorized access, right? So let's move to the next point, and let's try to understand this particular service in more granular detail. So whenever any user is trying to access any particular application which is hosted in the data center, right, how it is going to work? So let's say you have your Zscaler cloud. We have ZPA public service edges, just like ZIA. Sorry, public service edge, right? These are your public service edges for ZPA, right? You need to make sure that we are talking about ZPA now. This is not your ZIA cloud. This is ZPA cloud. Okay. So your users using client connector to access the applications which is hosted in your private data center or in your private cloud, right? Let's say here is your application server and we have spent the app connector on premises. Let's say any user is trying to access xyz dot local. This is your local portal. So when the user is going to open up the browser and it is going to hit for this URL, what your ZCC is going to do, ZCC is going to intercept this particular request. And if you remember, when you are going to do the enrollment, we already have this outbound tunnel, which is your Z tunnel. Similarly, from here, you already had your tunnel with the service edge, right? So when ZCC is going to intercept this particular request, right? So ZCC will try to, reach out the Zscaler Zscaler Central Authority to get the connection for this particular application. Now your CA is going to nominate the service edge for the connection so that app connector can establish the tunnel with that particular service edge so that both these clients, I mean ZCC and your app connector can meet at middle point. This is the middle point where they can meet. Now this nomination is done basis on best path available. So there is an algorithm which runs inside Zscaler cloud and it is going to identify the best path for you to reach out that particular application. Right now, client and your app connector establishes outbound Z tunnels that is going to meet in the middle. Now you have these outbound tunnels. Now to access the actual application, right, we are going to have end-to-end micro tunnel. Now this tunnel is going to provide you access to the application if you are authorized. So what is going to happen? Within these within these outbound tunnels, we are going to have, let me use any other color. So let's use this. We are going to have micro tunnel like this. Like this. Now this is going to be the end-to-end tunnel. And this will provide you the access to the application. Right? So we have Z tunnels, and inside these Z tunnels, you're going to form micro tunnels, which will carry your TCP stream or UDP stream, whatever it is, to reach out to your application. Okay. Same behavior will be seen when you have hosted your application in your private cloud, be it AWS, Microsoft Azure, Google, GCP platform, wherever it is. So these outbound connections will be used to form the microtunnels, and that microtunnel will be responsible for end-to-end delivery. Okay, so these ZPA service edge brokers, they are forming end-to-end microtunnel for access to only authorized applications, right? If the user is authorized to access this particular application, then only this microtunnel will be formed. Otherwise, the connection will be uh, not you can say form, or it is not going to form, right? So is it clear now, right? Same process we will follow for private clouds if you're making connections with the private clouds. Now there are certain elements which we need to understand to decrypt this particular technology, right? Because there are multiple elements which you will see in coming lectures, and first you need to understand those elements, because we will be calling them out frequently. So first element is applications. What is an application from Zscaler perspective, right? So FQDN or IP with a UDP or TCP port range considered as an application, right? So you can configure applications with their FQDNs or IP address inside Zscaler Cloud for their discovery, right? You can use automatic discovery as well, and you can use a wildcard to discover your applications, right? So if I will talk about any user is trying to establish connection with your DNS server, right, on port 53, Zscaler will consider this transaction as an application on your application will be DNS. So during auto discovery, you will see in the portal that you might have discovered 3000 applications, but that is not going to be the real scenario. It might be possible that these are the 3000 uniquely identified applications, but in reality, we only have 600 applications. And these 600 applications, they are using more than one URL. And whenever any URL gets, user is accessing, Zscaler is considering that particular URL as an application. So we group them, right? We group them and we create application segments. Now, what is application segment? So container for one or more application. So you can group them by type, protocol, privileges, target audience, right? You can do that. Then these application segments are further called inside segment groups. Now, what is a segment group? Container for multiple application segments, and we are going to use it to for access policy, timeout policy, right? To configure your policies. So this is going to be like this. We have apps, we have multiple applications, right? We create app segments out of these applications, and then we call these app segments inside segment groups to configure the policies. I mean, in coming lectures, it will be crystal clear to you when we are going to do the configuration and we are going to do the real-time simulation, then it will be crystal clear. Right now, you won't be able to understand it, in a full pace. So it is expected. One thing to note here is an application segment must be a member of single segment group. You cannot do this that this application segment, let's say we have created one application segment, internal apps, and you're calling this segment inside multiple segment groups. You cannot do that. So one application segment must be a member of single segment group. Okay, because you have already done the grouping of the applications, and then you're doing the grouping of your application segments to apply the policy, right? So you cannot have multiple groups for a particular app segment. Now moving forward, this is all about it, application layer. Then for servers, your picture goes like this. We have servers, your actual servers, where your applications are running, right? We turn on the dynamic server discovery, which is recommended from Zscaler. And then it is going to, your segment groups are going to discover these servers. Sorry, this is not segment, it is server group, right? So we are going to create server groups. So initially, when you're deploying this service in the infrastructure, we need to turn on dynamic server discovery. So dynamically, Zscaler is going to discover your servers and you're going to map it to the server groups, or you can create your own server groups and you can attach your servers. Now, how this is being performed? So the technology behind is your app connector. When you're going to spin these app connectors in your on-premises, be it your private data center or your cloud, so whenever any application request is going through them, they're discovering that application as well as that server, right? And we integrate the, we also integrate our local DNS to them. So they get the leverage to discover these servers wherever your application is hosted. And initially we open wildcard rule, whatever is your domain, we open wildcard. Let's say we have this star.test.com, right? So whatever URLs you have, right? Let's say support.test.com, software.test.com. So whatever URL users are going to access, accordingly, these app connectors are going to discover your servers. We also group them, right? We create app connectors group. So app connectors group. Now you will get confused why we are doing this grouping and all stuff, right? So to give you answer to that particular question, now we need to create a middle point where these application segments and these app connector groups they can meet, right? And this is going to establish a relationship between the application and the app connector. And whenever any user is trying to access that particular application, you know, your data can be travel through the micro tunnel. So what happens? We have the app connectors. We have your app connector group. So let's say you have 3 app connectors in your London data center. You have 4 app connectors in your US data center. You have created the groups accordingly, right? So that we can discover the apps properly and we can find optimal path to the application, right? We have groups here, app connector groups. Let's say you have 2 different groups. These 2 connectors are in London. So I'm going to map these connectors in London group and this is in US. Okay. Now, what you need to do is you need to establish a relationship between the application segments and these app connector groups. And you will be doing it with the help of the server group. So we have this server group, different server group. Let's say this server group is in US and this server group is in London. So you will form a relationship. Okay. So the server group is the central point for mapping of application segments to the app connector groups. Okay. These are your server groups. Now your applications. So coming down to your applications, your apps, they are already mapped to application segments. So let's say you have different application segment. This is your US based application segment. This is your London based application segment. And similarly, we have a segment group to enforce policies, to create policies by using this segment group, right? So now this group, app segment will meet with the app connector group on server groups. So this is how your connections will be established, right? I'm just drawing these arrows just for reference, don't get confused why I'm creating 2 arrow, 3 arrow, just for reference only. It will get much clear in coming lectures when we are going to implement this technology and when we are going to walk it through, right? So then it will become more clear to you. So this is the middle point right here. So here your app connector group and your application segments are meeting, right? So you need to add your app connector groups and server groups for application in the same physical logical location. What does that mean? It means if your applications are running in a subnet, then make sure that your app connector is also part of this subnet. You cannot spin your app connector in any other subnet, right? So your app connector should be part of the same subnet so that it can participate in the discovery process and it can locate your servers. Okay. So you cannot have your app connector in a different subnet. Now, if you're going to group your application instances, right? What would be the best practice for that? So let's have a look, right? It will give you more clear understanding what we have just discussed here. So let's say you have your two data centers. One data center is here, and you have your application instances as well. You have multiple applications here. These are your different application instances, your internal applications. Similarly, you have your backup data center, or you have a different data center in a different region for your regional audience, right? And this is on Azure. This is on premises private, this is Azure, right? And you have your application instances here as well. Although these applications are same, but the instances are different because they are geographically on different locations. Now, we are aware that we need to spin app connectors within the same subnet so that app connectors can perform the application discovery. Okay. So now what will you do? You will create server group for DC1, your connector group, connector group for DC1, that is this. So these app connectors will be grouped here. Similarly, you will have another group, app connector group, that is your, this is group 1 and this is your connector group 2. For Azure. Now these app connectors, they will be mapped with this particular group. Similarly, you will create two server groups. Server group 1, server group 2. Right? And you're going to do the mapping like this. This is attached with this. This is attached with this. So these two connectors are attached with this server group. These two app connectors attached with this server group, because server group is going to be the middle point where your application segments are going to meet. Now, your application segments, let's say we have DC1 apps. This is the name of your application segment. And we have another application segment, that is your Azure apps, because you can configure any name, right, for your app segments. So DC1 app will be attached to this server group. Azure apps will be attached to this particular server group, right? And this is how your traffic will be segregated. So if user is from, let's say this is DC1, this is let's say LDC, your London data center, and let's say this is your US based data center. So if users are coming from London or any EMEA region, so they are supposed to connect with LDC, right? So their traffic will go like this. They're part of this. They need to access this particular application segment, instance. Similarly, if somebody is accessing this service from US, then it will go like this. I mean, although this is not going to be your actual packet flow, I'm just giving you a reference here. You know, this is how we are going to prepare our configuration map when you are going to do the configuration, right? When you are defining your app segments, creating the groups, right? You need to define the complete configuration map where these elements are going to reference each other, so that when you're going to configure your access policy, a correct policy, a correct rule can be implemented for a user. Okay, because your access policies, timeout policies, client forwarding policies, they will be attached on either application segment or segment groups, right? And we do have different criterias which we are going to explore going forward. So this is an overview about the ZPA service. Now we have multiple services like ZPA, app discovery, how it works, right? Then we have this particular thing, when how best path is discovered from the Zscaler cloud, right? And how the connections are getting formed, right? So potential application paths, then path selection criteria, what would be the criteria to select the path if we have multiple paths available. And if you're calling any particular app connector group inside the access policy, then how your traffic will be routed, right? So these things we are going to discuss in coming lectures, right? And if you need complete training on ZPA, then it is available on our website. You can visit ngcloudx.com. I'm going to provide the URL inside description as well. And we have separate portals for international students and a different portal for Indian students, right? So main website is ngcloudx.com. And for Indian students, we have a separate portal which you can access on learn.ngcloudx.com, right? So do visit our website. You will soon see a ZPA course as well. Zia and Palo Alto training is already available there, right? And ZPA training, complete training will be uploaded soon. Thanks for watching this video.